In the woods.
All right, working a couple of problems here first, guys. You guys try to follow me on paper as we do this. We're just gonna do straight up vector addition problem first. Let's say that we had a plane that was heading due east, and let's say its engines were carrying it at 345 meters per second. So it's probably a jet, right? Because it's going really fast. It's like a fighter jet. But let's say there's also some wind. And the wind, let's say, is blowing north at maybe 50 meters per second. That's probably a pretty fast wind. And what we want to know is what's the resultant velocity of the jet. So without any wind, it would be going 345 meters per second due east. But there is wind. And the wind's going to blow it off course a little bit, right? So what did we call the method of vector addition that we're supposed to be using in here? Tip to tail. So we're going to start with either vector. It doesn't matter which one we start with. I think I'm going to start with the horizontal one. So let's say this is the point we're starting from, right here. We're going to go due east. Remember that's 345. And then we come over to the tip of that first vector, and we draw in the second vector. It's going north at 50. All right, so we've got them drawn tip to tail. And now we have to draw in our anchor line, the line that represents the sum of those two. And what's that called? It's called the resultant. And that goes from the tail of the first one to the tip of the last one. That's a little curvy, but it should be straight. But that's our resultant. And since this is a 90-degree triangle, it's easy to find that. Just Pythagorean theorem. So we'll go r squared equals 345 squared there plus 50 squared. So if we go through and do the math on that, don't forget to take the square root. We get about 349 meters per second. Now that's our resultant magnitude. What do we still got to do? Got to find the direction part, the angle part. And remember, so that we're consistent, the angle that we always want to find in this class is the smallest angle between the resultant and the horizontal, which in that case would be that angle, the one that I marked with red. And what would be the easiest way to find that angle? Just from looking at the picture, what's the easiest way to find it? Tangent. We call this theta. The tangent of our angle theta, is opposite 50 over adjacent 345. So again, if we do the math on that, 50 divided by 345, and do the inverse tangent. So that comes up to be 8.25. So our answer is going to be 349 meters per second with a heading of 8.25 degrees. What do we need to put on the end of that? North of east. And that means, again, start over here at east and move toward the north 8.25 degrees. So the answer you would give me, you got to give me all of that to get it right. 349 meters per second, 8.25 degrees north of east.
If we did it the other way, like instead of doing the 345 tip tail first and do the 50 first, wouldn't the angle be different?
Yep. Let me show you how. What Tara's saying is she started with the 50 first, and then she drew in the 345. this. Remember, this is our horizontal. So we had to draw in the resultant. What you're going to have to do first is you're going to have to find this angle. To find this angle, which is the one that we need, this angle right here, you're going to take 90 minus whatever that angle is there. So you're going to find that angle to be 81.75. But the angle you always want to give your answer in is the angle between the resultant and the base, which is still going to be 8.25. So you're going to have to find another angle to find them. And that's why if you have a choice there, it's easier sometimes to start with the horizontal, and that way you don't have to do that extra step. Yeah. What now? That's the next example. Might as well go ahead and do that now. Let's say this time, instead of having straight up and down the right triangle, let's say that we have one, say we're doing forces. Maybe we got a box this time. And somebody's pulling on the box with a force of, say, 40 newtons at an angle of, let's say, 50 degrees north of east. So our box is right here at this dot. So somebody's pulling on the box 50 degrees north of east with a force of 40. And let's say somebody else is pulling on the same box from the same point due west at, let's say, 20 newtons. So we've got two ropes hooked up to that box. One person's pulling at a 50-degree angle with a force of 40 newtons. Somebody else is pulling straight due west with 20 newtons. And we want to know what's the net force acting on the box. It's a total force if we add them all together. Any ideas how we would do this? All right, there's several different ways you could do it. You could just draw it tip to tail. And then the math gets a little flaky. You've got to use what's called the law of cosines or the law of sines. You guys familiar with those? I think Coach Massey probably teaches it that way. I'm going to teach it the way I think is better conceptually and easier to do. The first thing you're going to do when you have vectors that aren't at 90-degree angles to each other is take each individual vector and break it into vertical and horizontal components, which we looked at yesterday. So draw down a 90, draw in that first vector, draw down a 90, solve for V, and solve for H. So we're only looking at the red vector right now, the 40 Newton vector, 50 degrees north of east. We drew down a 90, and now we have a vertical component, which instead of calling vertical, I'm going to call that my north component, right? That's the part going north. And instead of calling this a horizontal, which way is that part going? East, right? All right, so to solve for the north component, what do I need to use? How can I find the end there? Look at my picture. Here, lots of silence out there. How about you sine of 50 equals opposite over hypotenuse? That works, right? So if I do the math on that, essentially I'm going to go the sine of 50 times 40, right? So that tells me 30.6. And that's 30.6 newtons going which way? Going north. Now I do the same thing for the horizontal component, the east component, except I don't use sine, I use what? Well, I could use Pythagorean theorem, but it's faster here just to use cosine. Cosine of 50 equals adjacent over hypotenuse. So I'll just go cosine of 50 times 40, and I'll get 25.7. That's 25.7 newtons going to the east. You can put north. I use the arrows because I was dealing with newtons, and I didn't want you to confuse north with newtons, and that's fine. But either way is okay. But that's why I chose the arrows, so you wouldn't do that. All right. So far we dealt with this red vector up here. We just broke it into components. For the green one, the 20 newtons west. Can we do that? It's all west, right? No need to break it into components. So let's think about what we have so far. We've got a 30.6 newton component north, a 25.7 newton component east, and a 20 newton component west. What can we do with this one and this one since they're in the same dimension? Just subtract them from each other. Okay. So now we put those components together, the east-west components together, and we end up with 5.7 newtons going which way? Going east. And we still have 30.6 newtons going north. You guys see now how we can get an answer here. We have a north and an east. What can we do? Tip to tail. Now I'll do a triangle. So before I do it, let's make sure we get the big picture. If you have vectors that are not at 90-degree angles to each other, take those vectors and break them into north, north-south, and east-west components. Then put the north-south ones together and the east-west ones together. And then finally, the step we're about to do a triangle. Do a tip to tail. So let me make a little space up here at the top. So we have a 5.7 newton east and a 30.6 newton north. I'm going to do the 5.7 one first. So 5.7 going to the east, and then 30.6 going to the north, tip to tail. Then we need to draw in our sum line, which again is called what? A result. Going that way. That's R. So use Pythagorean theorem. R squared equals 30.6 squared plus newtons 5.7 newtons squared. So if we do the math on that, $31.1. Oops, not 6, 31.1. And that's newtons, but that's just the magnitude. We still got to find an angle. And remember that, again, the angle that we always want to find, so we're all consistent, is the smallest angle between our resultant and the horizontal. That angle right there. And we can find that angle using tangent. Call this theta, and we can say the tangent of theta equals opposite 30.6 over adjacent 5.7. So do the math there, 30.6 divided by 5.7, and take the inverse tangent of that. 79.4. So our answer, 31.1 newtons, 79.4 degrees, what? North of east. All right, so again, if you have two vectors that are not at 90-degree angles to each other, break them into vertical and horizontal components. combine the vertical components from the two different vectors, combine the horizontal components from the two different vectors, and then once you do that, then you can go and you can do a triangle, a tip-to-tail method, and you'll get your answer. Let's do one more, and I want you guys to take a minute and try this one on your own first. It'll be like that one. So this will make it maybe a little bit more complicated than that one now. This time, let's say we have a plane, and let's say this time the plane is headed this way, and let's say it's headed with a velocity of 225 meters per second, and it's going at an angle, let's say 35 degrees, and that would be north of west. And let's say there's a wind, so this is the plane. And let's say there's a wind blowing this way. And let's say the wind is blowing at 40 meters per second. And let's say that it's blowing at an angle of 20 degrees. And that would be south of east, right? So you got a plane trying to head northwest, 35 degrees north of west. You've got a wind that's trying to blow it 20 degrees south of east. And what I want to know is, what do these add up to be? So again, first, break them into components, vertical and horizontal. Second, combine the vertical with the vertical and the horizontal with the horizontal. And then finally do a triangle to get your resultant vector. I'm going to pause the recording there for a minute. And I'm going to give you guys a minute to work on it. Alright, so remember what we're trying to do is add these two vectors together. And like I said before, the first step when you have vectors that aren't at 90 to each other is go ahead and draw down a vertical on both and break them into components. Do what's called vector resolution. So let's deal with this first one. On this first one, we're going to have a northward component and we're going to have a westward component. And on the bottom one, we're going to have a southward component and an eastward component. So we're going to use sine and cosine to do this. So let's start up here on the top. Remember, this is the 35-degree angle right here. So to find that north component, we're going to use sine. We're going to say the sine of 35 equals our north component opposite over our hypotenuse. And to find the westward component, we'll use cosine. Cosine of 35 is the adjacent component over the hypotenuse, 225. So if we calculate that real quick, sine of 35 times 225, and that gives us 129.1. I'll carry out one extra significant digit for right now, and then we're going to do the cosine of 35 times 225, and that gives us 184.3. And remember, this one is a north component, and this one is a westward component. And we come down to the bottom and we do the same basic kind of thing. Remember that this angle right here is the 20-degree angle. So to find that south component, we're going to use sine. And we're going to say the sine of 20 equals our opposite side over our hypotenuse. And to find the eastward component, we'll use cosine. Cosine of 20 equals east over 40. So do the math. Sine of 20 times 40. So that's 13.68. And that's meters per second. And that is going that way, south. And then on this other one, cosine of 20 times 40, 37.68 37.59. And that is an eastward component, so that is going this way. All right, so we broke it into components. Now we're going to take our vertical components and put them together. So we're going to take this and this. And since they're going in opposite directions, what do we need to do? Subtract. So 129.1 minus 13.68. So we end up with a vertical component here of 115.42. And that's going which way? North. The north wins the tug of war, right? He's bigger. So that's our vertical component. Now we're going to do the same thing with our horizontals. We're going to take that one and that one. Put those two together. So west is going to win this tug of war, right? So we're going to take 184.3 and subtract from that 37.59. And when we do, we end up with 146.71, and that is going to the west. Now all we have left to do is what? Tip to tail with our components. So let's make a little space down here. That doesn't want to erase. I guess we'll just leave it. So we'll come over here and we'll go, I like to start with the horizontal, so we're going to go this way. 146.71. And then we'll go north. And that's 115.42. Drawing our resultant. Like that. Do a little Pythagorean theorem. R squared equals 115.42 squared plus 146.71 squared. Take the square root, and we get 187. So that's our magnitude, that's our speed, right? That's our speed. But I didn't ask for speed, I asked for what? That's for velocity. So what do we need to make that a velocity? What are we missing? The direction. We got to find the angle. And remember, the angle we always want is the smallest angle between our resultant and the horizontal. So that's the angle we're looking for right there. And to find that, if we call that theta, the easiest way to do it would be tangent. So it's opposite over adjacent. So the tangent of theta would equal 115.42 over 146.71. So we divide that out, 115.42 divided by 146.71. We take the inverse tangent, so we get 38.2 degrees. .2 degrees what? North of west. So again, that means start over here at west and go 38.2 degrees toward the north. That is our final answer on that problem. Does that make sense? Hey, what you got? Okay, thank you. Maddie. Marie. I'm going to stop the recording again here for a minute.